Hello friends. So now question number 6, we are going to discuss how can wing bending moments be reduced in flight. What are wing bending moments? See, we can see that we can see that this is the aircraft and this is the wing being attached. So this is the nose. We can see the fuel are there in these wings, and whenever this aircraft flies, these wings, there is a tendency to move upward, and this is called wing bending moment. So we will see what are the options. By using aileron up float and keeping the center section fuel tanks full as long as possible. Center section fuel tanks full as long as possible. No. Why? Because we will see the B, by using aileron up float and using the fuel in the wings last. This is the option because center section fuel tank fuels are consumed first. So option A cannot be right. Option B is right. Option C, by having tail mounted engines and using aileron down float. See, tail mounted engines is not logical at all. By having wing mounted engines and using the wing fuel first, this is also wrong. So P is the correct answer. Here we can see that in the bending, stress relief is also provided by using aileron up float, mounting the engines on the wing and positioning the major fuel tanks within the wing. During flight, the fuel in the wing tanks is the last to be used. So here we can find the mentioning of all options. Question number 7. Regarding a safe life structure. What is safe life structure? Option 1, will only fail after a known number of operations or hours of use. See, for a structure of the aircraft, we don't let the structure of the aircraft to fail at any time. So option 1 is wrong. Should not fail until a predicted number of fatigue cycles have been achieved. True, because in the AFM we provide the structure limitations restricted with flight cycles, that is for larger aircraft number of pressurization cycles. One flight cycle equal to one pressurization cycle. So option 2 is right. Has a programmed inspection cycle to detect and rectify faults. True. We have visual inspections at the given interval as per the MPD, that is being translated into the aircraft's AMP. It changed. A safe life structure is changed before its predicted life is reached. True. So we see answer is C. This is also we never let the safe life structure limitations to be reached at any time. These are design philosophies. See, what does a safe life philosophy tells? Design philosophy. A safe life of an aircraft structure is defined as the minimum life during which it is known that no catastrophic damage should occur. Life counts for components of assemblies may be recorded as a number of flying hours, cycles of landing, pressurization events, accelerations, or even on a calendar basis. After the elapsed life count or fatigue cycle, typically pressurizations or landings have been reached, the items is replaced or overhauled in the interim operational life of the aircraft. And to minimize the changes of failure due to fatigue, aircraft designers apply the principle of fail safe construction or damage tolerance, as we have discussed. Now we come for question number 8. What is a fail safe structure? We have discussed has a programmed inspection cycle to detect and rectify faults. This we have studied just right now. It changed before its predicted life is reached. No, this is not a fail safe structure. This is the design philosophy. Has redundant strength which will tolerate a certain amount of structural damage. True. Is secondary structure of no structural significance. Not really related. So answer B is correct. 1 and 3. A fail safe structure has a programmed inspection cycle to detect and rectify faults and has redundant strength which will tolerate a certain amount of structural damage. Question number 9. The skin of a modern pressurized aircraft. A is made up of light alloy steel sheets built on a monocoque principle. No, because outside the skin, outside the airplane, these are frames, multiple frames, that is being aircraft is made up of upon, and these are stringers which pass through these frames, and upon it the skin is there. So basically skin is not in a monocoque structure from starting to last. We have a skin in a divided structure that is being riveted one upon another. We have seen if you see a video of a structure repair of the aircraft, the two skins are riveted. So it is not a monocoque principle. So one is basically not logically correct. Houses the crew and payload. Basically it is not the case because whole of the structure is going to do that. Provides aerodynamic lift and prevents corrosion by keeping out adverse weather. Adverse weather is right, but provides aerodynamic lift is not very much related. D. Skin is primary load bearing structure carrying much of the structural load. D is the correct answer. Of all the A, D is the correct answer. See, we can read about the skin. Skin takes the loads due to differences in air pressures and the mass and inertia of the fuel, if any, in the wing tanks. It generates direct stresses in a span-wise direction as a response to bending moments and also reacts against twisting torsion. Question number 10. The primary purpose of the fuselage is to see, this is the structure. This is whole of the fuselage. And these are wings. These are wings. And this is a fuselage. So we can read the primary purpose of the fuselage is to support the wings. It is one of the purpose to support the wings, but not, we will see, not the primary function. House the crew and payload. Definitely, the fuselage houses the crew and payload. Keeps out adverse weather. One of the work, but not primary purpose. Provides access to the cockpit. One of the thing, but not logically 100% right. So the primary purpose is to house the crew and payload. That's all for today. Thank you. Thank you.